Hello everyone, today let's solve the problem number 73, set matrix 0. So what the question states here, we are given an m into n integer matrix, and if an element is 0, you can clearly see here, we are given an m into n matrix, right? So if an element is 0, then we have to set its entire row and column to 0 and place, right? So that's what the question states here. You can clearly see. Let's come to first example here. We have 0 in the middle, right? So we have to set this entire column to 0, and we have to set this entire row to 0 as well, right? So that's what they have given in the question. So same goes with example 2 as well. We have two zeros in the entire matrix, this one and this one. So here this one has to be 0 and this one has to be 0 as well, and this 0 for this 0, this column has to be 0 as well, because this row is already 0, this column has to be 0 as well. You can clearly see here 0, 0 and 0. Same goes with first example here. So here we are making this row entire row 0 and this entire column 0 accordingly with the question. That's what we need to do. I hope the question is completely clear. This is easy to understand, right? They have clearly mentioned in the diagram. They have given wonderful diagram here so that we understand this one clearly, right? So I hope the question is completely clear. First, what we'll do, we'll discuss the approach followed by the edge cases, and finally write the code and discuss the complexities of the code that we have written. First, what we'll do, we will discuss the approach. So here you can clearly see I have considered the same example, first example that they have given in the question, right? So that it will be easier to understand. We have already discussed this one, what to do. We know what to do. So we'll just discuss the thought process. So and finally we can just discuss how can we articulate that one in the form of code while we write the code, right? So this is the output that we need to get. So here first thing we need to keep in mind here is we will be going with the in place marking approach, in place marking, rather than using the result array, extra space. Rather than using the extra space, we'll be going with the in place marking. So here the space complexity would be big of 1, right? So we will be going with the in place marking rather than considering extra space or the extra resulting array. So here the approach that we'll be going with here is optimize in place marking, right? So first step here is we have to identify the rows and columns that needs to be 0, right? So we need to identify the rows and columns that needs to be 0 in this case, right? So here 1 1 1 1 0 1, we have already discussed this one. 1 1 1, this row has to be 0 and this column has to be 0. So this entire row and this column has to be 0, right? So here this is first thing we need to consider here. If matrix of ij equals 0, then mark the matrix of I0 equals 0 and matrix of 0j equals 0. This one we will be doing. So here matrix of ij is 0. We will mark matrix I0 and 0j, this one I0 and 0j equals 0. At this step matrix becomes this one, you can clearly see here. So now we are converting this matrix basically. This one I have written here, you can clearly see 1 1 1 1 0 1 1 1 1. This one we have considered, right? This one will be converted to this one 1 0 1 0 0 1 and 1 1 1 at this step. This is the first step, right? So we are identifying rows and columns that needs to be 0. First step here is if matrix of ij equals 0, then we will mark matrix of I0 and matrix of 0j as 0. This is fine. And the second step here is we will use indicators to set 0. So in this case, if matrix of I0 is 0, matrix of 0j is 0 as well. If matrix of I0 is 0, then matrix of 0j is also 0, then matrix of ij is also 0. So this one is 0, this one is 0, then this one is 0 as well. They are same, right? This one is 0 as well. Matrix of ij is 0 as we are setting ij equals 0, right? So if matrix of I0 and 0j, this one I0 and 0j is 0, then we have to set the matrix of ij 0. Nothing but in this case, this one will be 0 and this one will be 0. So the output matrix here will be 1 0 1 0 0 0 and 1 0 1. So this is the output that we need to get, right? So we have to handle the first row and column. Here we need to handle the first row and column. So if matrix of 0 0 is 0, set the entire first row to 0. If matrix of 0 0 is not 0 here, so here we have 1, you can clearly see. If matrix of 0 0 is 0, set the entire first row to 0. If the column is true, we will set the entire first column to 0 as well. But here in this case we have 1, right? So we will set this one to it will be as it is, 1 and 1, this will be as it is, will not change anything here in this case, right? So the final output that we got here is, here itself you can clearly see 101 000 101. So this one 101 101 000 and this one 101. So that is the output we got here. So this is the final output. So the output that we got here, this matches the output that they have given for the example 101 000 101. Let's check that one, 101 000 101. So this approach works absolutely correct in this case. This is the step-by-step explanation, or step-by-step. This is the thought process basically. This is what we will be articulating this one in the form of code. See here, we have just changed in place. We'll be changing in place rather than creating the result array and returning the output and a result array. We are just going for the in place change here by making use of only 3 steps. So in short, we are identifying the rows and columns that needs to be 0. Here, this step we will carry on. We have already discussed this one. Just look into it. Step 2 here is, we will be using indicators to set 0. We already have I0 and 0j as 0. So we will set the matrix of ij is 0 equals 0 here in this case. And third case, in our case, it is 1. If matrix of 0 0 is 0, set entire first row to be 0. But in this case, we have 1. So we don't have to care about this. So if each column is true, then we will set the entire first column to 0 as well. Right? In this case, we actually had here this one. What do we call? We didn't had this one 0, right? Here we had initially what we had. So just give me a second here. Got confused here. So yeah, 1, 1 and 1 we had for the column. So we don't have to care about this one. Each column is false in this case. So it will be as it is. The numbers will be as it is for the column, right? So the final solution that we got here is this one, which matches the output that they have given for the question, first example. So I hope the approach is completely clear. Let's discuss the edge cases here. So the first edge case that we'll be dealing with or discussing about here is full 0 row. Here full 0 row, we have 0 1 2 0 3 4 5 2 1 3 1 5 in this case. So the output will be in this case it will be 0 0 0 0. So this will be 0 4 5 6 in this case. Sorry, there is no 6 0, right? This has to be 0. Yeah, 00 00 0 4 5 6 0 4 5 0. Sorry, 0 3 1 0 in this case, right? So this will be the output here. So here this is for the full 0 row. This is for the condition full 0 row, right? So I hope this is clear. The second edge case that we need to consider here is matrix 1034 we have here. 1034 we have. So the output matrix will be here. In this case, it will be 0 0 0 0 because we have 0 in this, right? So we have only one this one row. So we will convert entire row to 0. Here in this case, we had 0. This whole column becomes 0 here, and we had 0 here. This whole column becomes 0 as well, and we have 0. This row also becomes 0. This one we have already seen this one in the example, right? So I hope this is clear. Second edge case is also clear. This is for the single row matrix, and the third edge case here is matrix single column matrix. In this case, we have 1 0 3. So this entire column has to be 0 in this case. So it will be, sorry, just give me a second here. this will be 0, or let me do one thing here. Yeah, let me consider here 0, 0, 0, right? In this case it will be 0, 0, 0, means entire column will be 0 if we consider output in this way. So it will be 0, 0, 0. So output will be 0 because we have to convert the column and row. So we have single element in the row, so this is already 0. This entire column becomes 0 here. So this is for the third edge case. These are the three edge cases that we need to consider. First edge case was for full 0 row, and the second edge case was for single row matrix, and the third edge case was for single column matrix. I hope these three edge cases are completely clear, right? So next what we will do, let's start writing the code here. So let's start writing the code. Initially, as discussed in the approach, we will set is column to false initially. So is column, initially we will set this one to false, right? So row, we will set this one to the length of the matrix. We'll be making use of the length of the matrix again and again. So let's initialize this one to r, or let's assign this one to r. So I'll just give your matrix dot length. The next one here is a column. Let me set this one c equals matrix of 0 dot length here. So this is fine. We are setting is column to false, row length of the matrix, and column to matrix of 0 dot length, right? So the first step here is we have to identify the rows and columns that needs to be 0. That was the first step, right? We discussed this one in the approach. So for loop here, let I equals 0, I less than r, I plus plus. This is fine. So here we have to track if the first column has 0. We are tracking if the first column has 0. So in this case, if not of matrix of I, this one 0, then what we will do, we will set is we'll do one thing, is column, we will set this one to true. So this one, if not of matrix I 0, so if 0 is present in the column, then we have to set that whole column, this one is column to true. Nothing but we are tracking if first column has 0 or not. If it has 0, then we are setting the is column to boolean value true, right? So the next step here is we will start from the column 1 to avoid the overwriting, right? So we have to avoid the overwriting, right? In this case, that is the reason we'll be starting from the column 1. Again, for loop here, let j equals 1, j less than c, and j plus plus. Increment the j here. So if not of matrix of I j, what I'll do here, matrix of I0 we will set this one to 0, matrix of 0j we will set this one to 0. Means we will mark the row indicator and we will mark the column indicator here. So that one we can articulate this one in the form of code in this way. Matrix of I, this one 0, this one we will initialize this one to 0, and matrix of 0, this one j, this one we will initialize this one to 0 as well. So we will mark the column row indicator as well as the column indicator here. This is fine. So let me come out of this loop entirely. Next step here is, let's move on with the step 2. So we have to use the indicators to set 0. So for loop again, for let I equals 0. Sorry, we have to start with 1 right here. 1, I less than r. This one, let's increment the I. We have j as well. For let j equals 1, j less than c column. Let's increment the j as well here. So again, if not of matrix here, matrix of I 0 here, so or not of matrix 0 j here, so then what we will do, matrix of I j, this one will be 0. Means we will set 0 if row or column indicator is 0. here we will set if row or column indicator is 0, right? So that's what we are doing here. We are making use of the simple if statement here, if condition, right? So this is fine. The final step, not the final step, sorry. Let's move on with the third step. We have to handle the first row if it is needed. So here, let me come out of this loop entirely. So again, simple if condition. We have to just handle the first row if needed. So this will be matrix of first row, matrix of 0, 0 here, right? Sorry. So this one bracket. So this one, let me write the for loop. Let j equals 0, j less than c, as this is the this one first row. So here let's increment the j. This will be matrix of 0, j. This one will be 0. This is fine. So the next step or the final step here, we have to handle the first column if needed. So here we are handling the first row if needed. Next here we have to handle the first column if needed. First column we have already considered that one variable is column, right? So if of is column, then what we will do for let me give here I equals 0, I less than r, and let's increment the I here. So here this one will be I plus plus. This is fine. Matrix of I 0, this will be equals to 0. So I hope this is clear. Let me format the code once here and let me hit the submit button. So this is it. We don't already we have discussed this one. We are not returning anything. We are just changing we are going with the in place marking, right? Optimized in place marking. You can clearly see here. I directly click the submit button. I think this is fine. So all the test cases are getting passed here. Means the code works absolutely correct in this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is in place marking or optimized in place marking. So overall time complexity here would be big O of m into n in this case, right? So what will be the overall space complexity here? Overall space complexity would be big O of 1 in this case, right? So overall space complexity would be big O of 1 and overall time complexity would be big O of n m into n in this case. I hope this is clear. So I hope the solution or the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.